Okay, hi guys. So in this lecture, we'll be starting off with the IUPAC nomenclature. So let me put down the heading first. IUPAC nomenclature. So IUPAC stands for International Union of Pure and Applied Chemistry. So it has given some rules as to how we can identify certain organic compounds, so that the naming uh, of any compound is universal and people can actually exchange their thoughts or understanding of the various reactions that those compounds undergoes by uniquely naming those compounds. So for these purposes, we have the IUPAC has underlined some of the principles or the laws pertaining to the naming of a certain compound. Okay, so this stands for International Union of Pure and Applied Chemistry. Okay, so first we'll be saying, just let's just broadly um, define the way in which the IUPAC names are written for a compound. So first we write 2-degree prefix if they are any in any compound. Then we go to 1-degree prefix. Then we see word root. Then we see 1-degree suffix. And finally we write 2-degree suffix. Okay, so 2-degree prefix is also called secondary prefix. Okay, and this includes X, or we will see what is the meaning of X. X is just the X represents the halogens fluorine, chlorine, bromine, iodine. Then we have 1-degree prefix. 1-degree prefix is also known as primary prefix. So those include cyclo and things like that. Then word root actually include meth, eighth, etc., depending on the number of carbon atoms in the compound. Then we have 1-degree suffix, or it's also called primary suffix. Then this can include ene, ine, and something like that. Okay, then we have secondary or 2-degree suffix. It's also called secondary suffix. So we'll look into what is secondary suffix via some examples in some few minutes. So let's start off with 2-degree prefix. It's also called secondary prefix. Okay, so in 2-degree prefix, suppose we have a chain like this, and we have some substituent here, and the number of carbon atoms in this substituent is less than means even by including the number of carbons in this substituent, the longest chain still remains the above one. Hence, using these assumptions, we have to write this as a substituent. Okay, so in this case, the substituent is also known as locant, is R. Okay, so we have to write the 2 degrees prefix in naming the overall carbon compound, overall organic compound in this case, and we have to write the 2-degree prefix of the substituent. So what we do is we write something like this. The R is actually known as alkyl. This is the word we use for representing the substituent R as a 2-degree prefix. So if we have CS3, C2H5, C3H7, or we have 2CS3, these are all the various R substituents which we can have. So we'll be using methyl for this case. If we have this, then we will be using ethyl as the 2 degree prefix. This is propyl. This is dimethyl, and this is trimethyl. Okay, now this was one of the classes of secondary prefix. We can also have something like RO. So this is called alkoxy. This would be named as alkoxy. This is general pattern. We'll be seeing the actual names which would be there. Okay, so suppose we have CS3O, we can have ETO, we can have something like this. So this, the name of this would be, as an example, it would be methoxy, it would be ethoxy, and this would be propoxy. Okay, obviously we can also have halogens X. So for this we'll be using halo as a 2 degree prefix. Suppose we have F attached, Cl, Br, or I attached. So then for F we'll be using fluoro, for Cl we'll be using chloro, Br will be using bromo, finally I will be using iodo. Okay, so now let us talk about what if we have NO2 group as a prefix, as a substituent attached to it, NO2 group. Then for this group we'll be using nitro as the 2 degree prefix. If we have something like N3 attached, then this would be called azido. And if we have something like N double bond O attached, then the name for identifying this substituent would be in the organic compound as a 2 degree prefix would be nitroso. Okay, now let's talk about 1 degree prefix. 1 degree prefix is rather only we have few examples of substituents which should be identified as 1 degree prefix. So if our substituent, or we can say locant, is one of the following, something like this, that we have cyclic compound, then the 1 degree prefix used for identifying the cyclic compound is cyclo. If we have bicyclic compound, then we will use bicyclo. And if we have spiro compound, then the name remains the same, which is spiro. Okay, so with this we come to an end of this lecture. Till then, good luck and goodbye.